Assalamu alaikum students and welcome to another lecture of Slate. This is me, Khawaja Yasin. Let's study chemistry. In the previous two lectures, we talked about a very important chapter of O levels, that was chemical reactions. We talked about the rate of reaction and the collision theory. We talked about the equilibrium, the position of equilibrium and the factors. Now today, we are going to talk about the redox reactions. This is a very basic concept. This is an easy concept, most important for P1. You will see a few questions in P2, but mainly it's a concept for P1. There are many concepts here. So, what is redox? It's a combination of two reactions, that is reduction and oxidation. And these two reactions occur simultaneously. If one is happening, the other is happening. It won't be a case that this is only a reduction reaction, this is only an oxidation reaction. No. They occur together, and that is why we call them redox reactions. There's no dash between them. We just call them redox. So, what is reduction? What is oxidation? These are two just basic but opposite concepts, students. So, oxidation, reduction. Oxidation can be described in various ways. Oxidation is the gain of oxygen. A. B. It is the loss of hydrogen. It is the loss of electron. And it is the increase in oxidation state. Now, these are the four factors. I will discuss which ones are the important for O levels. Reduction is the exact opposite, students. Where oxidation was the gain of oxygen, reduction is the loss of oxygen. Oxidation was the loss of hydrogen, reduction is gain of hydrogen. Loss of electron, gain of electron, increase in oxidation number, decrease in oxidation number. But for O levels, we'll only be talking about the oxygen, the electron, and the oxidation state. The oxygen part is mostly related to the organic chemistry. In A levels, we will talk about hydrogen and oxygen both in organic chemistry, where reduction is the gain of hydrogen, oxidation is the gain of oxygen. In O levels, we'll only be stuck with the gain of oxygen or loss of oxygen. But electron and oxidation states, these two are the more important ones when we have to describe what is oxidation, what is reduction. Before that, we jump towards an example. What exactly is the oxidation state, students? When we talk about oxidation state, in easy words, if I have to tell you, oxidation state is the charge. For example, recall from the periodic table, group 1 will have a +1 charge. Group 2, +2. Group 3, +3. Group 4, +4. And as per the periodic table, we knew that group 5 will have a -3. But that's not fixed. The charge is there, but oxidation state can vary. Likewise, group 6, -2, again, that's the charge, but not the only oxidation state. We will just look into the examples. Group 7, -1, group 8, 0. These were the charges. And when we talk about transition elements, they can be anything. So, Oxidation state A. For transition elements, oxidation state is represented by Roman numeral. For example, we have iron sulfate. We know there are two types of iron. Iron plus 2, iron plus 3. So we will show that whichever oxidation state it is by just adding a Roman numeral. Plus 3 for Roman 3 for plus 3, Roman numeral 2 for plus 2. So that is the oxidation state. So, no for oxidation state. There are a few things that you need to keep in your mind. An atom or an atom or a molecular element will have, just like an atom has no charge, it's the ion that has charge. Likewise, molecular element does not have a charge. Will have an oxidation state of 0. Sodium, if it's just sodium, it's 0. If it's chlorine, Cl2, that's the molecular element, it's 0. But a compound will have an overall oxidation state or oxidation number of 0. But B8 ionic, B8 covalent, B8 ionic or covalent compound, whatever it is, be it ionic, be it covalent, the atoms or ions in the compound will have a charge. I won't say charge, will have oxidation state. Now the point is, if it's an atom, it has a 0 oxidation state. Molecular element, 0. They two make NaCl together. Now the whole NaCl has an oxidation state of the charge of 0. Compound is stable. And it's stable when there is no charge. So it has an oxidation state of 0. But when we have sodium in the same compound, sodium is in group 1, so sodium has an oxidation state of +1. Chloride, group 7, -1. So oxidation state is the numbers. Numbers are +3, +2, +1, 0, -1, -2, -3. And in this direction, students, the oxidation state or oxidation number is increasing. Obviously, -1 to 0, 0 is the higher value. So 0 is the higher oxidation state than -1. And +1 is the higher than 0. So let's look at the oxidation states. Now in this case, look at sodium. It was 0 here and it became +1. From 0, sodium became +1. 0 to +1, that is oxidation. And look at chlorine. 0 to -1. It's reducing the oxidation state. So this is reduction. So A, if one thing is getting reduced, the other is getting oxidized. If we talk about the same NaCl and we make half equations like electrolysis, that's the balanced equation, students. But if I make half equations out of it, we know sodium, when it becomes sodium ion, it is going to lose the electron. Sodium ion has lost an electron. Likewise, Cl2, when it becomes chloride ion, Cl2 will gain 2 electrons. So as for reduction in oxidation, loss of electron is oxidation. Here's sodium lost an electron to become sodium ion. It is getting oxidized. Chlorine gained electrons. It is getting reduced. So the same concept. We talked about oxidation number. We talked about the electrons. Now let's talk about another example, a very important one, which will cover the other concept as well. Copper oxide plus magnesium. This will form magnesium oxide plus copper. This is a simple displacement reaction. If we just talk about the oxygen, copper has oxygen here and it is losing oxygen. Here copper had oxygen, but now copper has lost its oxygen. So, loss of oxygen. What is loss of oxygen? Loss of oxygen, it's reduction. Magnesium has gained oxygen. It's oxidation. But that's not it. Let's talk about a more important concept. Oxygen is a less important concept. More importantly, we will talk about the oxidation states. Copper oxide. We don't know what's the oxidation state of copper, but we know there are a few oxidation states which are fixed. Group 1, Group 2, they have fixed oxidation states. Hydrogen always has +1. Oxygen always has -2. This is for O levels. In A levels, we have peroxide and hydride, but for now, for you, this is fixed. So we know about the oxidation state of oxygen. So O is -2. So how will I find the oxidation state of copper? It's a simple formula. Copper plus the oxidation state of oxygen -2. The total charge oxidation state is 0. So Cu -2 equals to 0 and Cu is +2. So oxidation state of copper here is +2. And here, it's just an atom, 0. Likewise, magnesium here is 0. Here, magnesium is +2. So from +2 to 0, that's the decrease in oxidation state, that's reduction. 0 to +2, that's an increase. 0 to +2 to 0, that's reduction. 0 to +2, that's oxidation. And if the examiner asks, they can ask you. If they ask you to talk about the oxidation or reduction, students, preferably you will talk about the oxidation number or oxidation state. That's what you have to talk about. But if they say, explain on the basis of electrons that magnesium is oxidized. In that case, I would just make this equation. Magnesium is losing 2 electrons So magnesium is losing 2 electrons to make Mg plus 2 ion. So that is why magnesium is oxidized. It loses 2 electrons. So that is how you can define it. That is oxidation, that is reduction. Now let's confuse you. That's an important part where students get confused. Oxidizing agent and reducing agent. Now, if you have electrons and I'm taking electrons from you, you just lost electrons. You got oxidized. But I have taken those electrons from you. I have gained electrons, you have lost electrons. Since you have lost electrons, you are oxidized. But I have got reduced. But who oxidized you? Me, myself, yours truly. So in that case, I am the one which is oxidizing you. I took the electrons from you. You got oxidized, but I am the one who oxidized you, students. So I am the oxidizing agent. But I got reduced, right? So what is an oxidizing agent? It is a species that reduces itself to oxidize the other. Likewise, reducing agent. It is a species that oxidizes itself to reduce the other. Now let me show you. Here, why is copper getting oxidized, reduced? Copper is getting reduced, but who is reducing copper? Magnesium. Magnesium is the one who took away copper's oxygen. So the entity which gets oxidized is the reducing agent, and the entity which gets reduced is the oxidizing agent. It's the opposite effect. So here, reducing agent, the one getting oxidized, that's magnesium. Oxidizing agent, the one getting reduced, that's copper. Here, sodium is getting oxidized. So sodium is the reducing agent. Chlorine getting reduced. So this is the oxidizing agent. That's all. Now, as I said, from group 5, 6, 7, they can have various oxidation states. You can be asked to calculate the various oxidation states. Simply, if we talk about iron first, we do not know which iron is which one. So we will just do the simple calculation. Iron plus 1 oxygen is -2, -2 equals to total charge. Total charge is 0. So here we have iron plus 2 charge. That's the oxidation state. Iron, but how many irons? 2 plus O3. So 3 into -2 equals to 0. So 2Fe minus 6 equals to 0. 2Fe plus 6 equals to 0. Fe equals to 6 divided by 2. So iron is +3. That is how you can calculate the state, students. A very important compound. KMnO4. Potassium manganate. Potassium, group 1. +1. Manganate, manganese, it's a transition element. We don't know about manganese. 4 oxygens. So 4 into -2. Total charge is 0. So Mn +1 minus 8 equals to 0. Mn -7 equals to 0. So manganese here is +7, students. That's how you calculate. Let's talk about sulfur. H2S, SO2, SO3, SO4 minus 2. Sulfur can have variable oxidation states. True. We know about hydrogen. Plus 1. How many hydrogens? 2. Plus sulfur equals to 0 as there is no charge. So plus 2 plus S equals to 0. So S equals to minus 2. So here sulfur has a minus 2 oxidation state. Sulfur plus 2 minus this. Oxygen is minus 2 and 2 oxygens. So S plus 4 equals to 0. S equals to, sorry. So S becomes plus 4. SO3. S plus 3 into minus 2 equals to 0. S minus 6 equals to 0. So S becomes plus 6 in this case. S can have variable states. Last one. Sulfur. We don't know about sulfur. 4 oxygens. The total charge is given of sulfate ion. That's minus 2. So that's where you put the charge. That's an ion. Polyatomic ion. So S minus 8 minus 2. S minus 2 plus 8. And students, that becomes S equals to plus 6. So that is how you can calculate the oxidation states. It's very important. Very important. Now, when we talk about oxidizing agents, there is one very important oxidizing agent in your syllabus. There was another one. Now, that's not a part of our syllabus. So we'll talk about the important one first. Potassium manganate 7, which means the oxidation state of manganese is plus 7. KMNO4. Now, this is the finest oxidizing agent. Why? It has Mn positive ion, which is purple, positive 7. It can be reduced to Mn plus 2, which is colorless. So if this manganese ion can be reduced itself, which means it can gain 5 electrons, and then it becomes plus 2. So it's getting reduced itself. This is getting reduced itself. What is it? This is a strong oxidizing agent. And why is it a good one? Because we also observe a color change. KMNO4 is purple. When KMNO4 is reduced, it is oxidizing something else. And when it is oxidizing something else, we see a color change. So, if I have two different beakers, A and B, and I add KMNO4 in both, note one thing, students. In the case of A, since I've added purple KMNO4, the solution remained purple. And here, colorless. So KMNO4 is an oxidizing agent. It is going to oxidize something. That something will get oxidized. But that something is also reducing KMNO4. So something which is getting oxidized is the reducing agent. And since KMNO4 is the oxidizing agent, it is getting reduced itself. Now, here we see no reaction took place. And here, a reaction took place, which means this proves that the entity B was reducing agent. Because an oxidizing agent is going to react with a reducing agent. Look at these equations. Sodium was an oxidizing agent, reducing agent. Chlorine was an oxidizing agent. They can react. Copper was an oxidizing agent. Magnesium was a reducing agent. They react. So an oxidizing agent will only react with the reducing agent. And if there is no reaction, the color remains the same. So potassium manganate, KMnO4, is used, and that is acidified. Acidified KMnO4 is used for the test of reducing agent. Now that is confusing. An oxidizing agent is the one which is getting reduced. But an oxidizing agent will tell us that the other entity is the reducing agent or not. Because if it changes no color, then it's not a reducing agent. But if it changes color, it's purple to colorless, the entity is reducing agent. So potassium manganate is the test for reducing agent. The color change we see is purple to colorless. The other entity was K2Cr2O7 potassium dichromate, also an oxidizing agent, and the color change was orange to green. That is for potassium dichromate, but that's not in the syllabus anymore. There is only one reducing agent in the syllabus. The main one. There are more, but this is the main one. Even chlorine is an oxidizing agent. When it reacts with a halogen, it will form KCl and I2. Iodide, I minus, say it has become I0. So iodide has oxidized. What has oxidized iodide? It is chlorine. So chlorine is also an oxidizing agent, but KMnO4 is the important one. Likewise, reducing agent, the important one is potassium iodide. So if I react potassium iodide with an oxidizing agent, just like this one, Cl is an oxidizing agent, we will get, for instance, we got KCl here plus I2. So iodide has oxidized for sure. But there is another important thing. Iodine has a color in aqueous solution. Aqueous iodine is brown. So a reducing agent is used for the test of oxidizing agent. So my known reducing agent, which is Ki, will tell me. So Ki is used for that. I know Ki is a reducing agent. So any entity I'm unsure about, I will react it with potassium iodide. And if the brown colors appear, that entity is oxidizing agent because iodide has oxidized. So here we have color change from colorless to brown. Now that is all about oxidation, reduction, oxidizing agent, reducing agent. But one last important tip for you, because in the paper they may ask which reaction is an redox reaction, which one is not. There are 3 not redox reactions. If you identify that this particular reaction is from this type, this class of reactions, you would know it's not a redox reaction. The first one, neutralization reaction, which is acid plus alkali. You can, for instance, ammonia plus HCl will form NH4Cl. If you take out time, you calculate their oxidation states, there is no change. No entity is getting oxidized, no entity is getting reduced. So if you observe that it's a neutralization reaction, that's a not redox reaction. Second, thermal decomposition. For example, calcium carbonate forming calcium oxide and carbon dioxide. Yet again, no change in oxidation state. Calcium has +2, carbon has +4, oxygen is still 3 into -2, oxygen is -2. Calcium +2, oxygen -2, carbon +4. This is 2 into -2. They all have the same oxidation states. Nothing has changed. And lastly, the precipitation reaction. You can go through the lecture of preparation of salts. Precipitation is explained in detail. Whenever you observe a precipitation reaction, which is aqueous plus aqueous forming an insoluble solid and an aqueous solution. So that is just a displacement reaction. There is no change in the oxidation state. So in this lecture, we talked about the oxidation states. We talked about the oxidizing agents. We talked about the reducing agents and their tests. And more importantly, the not redox reactions. So that is all for today's lecture. Thank you so much for being here with me. I hope this lecture helps you. Later on, we'll be discussing the past paper questions regarding these topics. So thank you so much for being here with me. Allah Hafiz.